We explained now all the irrigation systems and how they are classified and how the water and soil is described in each irrigation. And then now we go to the crops, and we take one of the crops here, like amaranth, for example, that's for Italy. And these are actually real data coming from one of the sites that was dedicated to test the SALTMED model. And here we have here maximum rooting depths, minimum rooting depths. The location is Napoli in Italy. And here we have the sowing date, and also have the harvest date. And at the same time here we have also minimum oxygen for water uptake. Some plants, they need a certain level of nitrogen, of oxygen before they start taking up water. And that's, we put here a default value. And also put here unstressed crop yield, that's yield under optimum conditions. There are here some parameters related to the plant, and they are given for 3 growth stages according to the FAO. And that's initial stage, middle stage, and end stage. And this is the crop coefficient Kc, the crop coefficient for transpiration KCP, fraction cover, and the height of the plant for each growth stage, the leaf area index, and pi 50. And pi 50 is the osmotic potential at which the actual water uptake is reduced to 50% of its maximum. And here we put information about the site. And here we put the lengths in terms of days for each growth stage here, and the total should be equal to the day of the harvest, which is there. We also put here the minimum temperature for growth. And there's another option here that for those who are looking for the impact of climate change on the crop growth and harvest date, they can actually run the model with what we call it here a degree days or heat units. So the plant does not grow according to these fixed dates or fixed number of days, but it would grow according to the number of heat units accumulated since the start, from sowing onwards. And for each growth stage here, if you work with degree days, you take the temperature of the day, you take from that or subtract from that the minimum temperature, and you add that up every day. And for each growth stage, you need some of these heat units until when you reach the maximum heat units, then you get your harvest. And that's important for people working with climate change. So that's really for the crops, and we have here, you can actually have here a new crop added to the database, or you use one of those available in the database and you adapt it slightly to your condition if you don't have enough information. Crop growth here, and this is really where you calculate the dry matter and the crop yield. And from here, the first parameter, that's the most important one for crop growth, is the photosynthesis efficiency. It's the amount of carbohydrate produced per megajoule radiation per meter square per day, which gives you gram carbohydrate accumulated per megajoule radiation per meter square per day. Most of the C3 crops, they are around 2, but C4 crops like maize, they are above 2 because they're more efficient in making carbohydrate. We have here some parameters related to the calculations of the crop growth, like extension coefficient and the photosynthesis active radiation ratio. This is 0.5, which means that 50% of the total radiation actually is actively involved in making the carbohydrate or the dry matter. We have here also some parameters related to sufficiency of the nitrogen in the leaf to allow more efficient efficiency or more efficient way to produce carbohydrate from a unit of radiation. And here we have also respiration effect, that the plant usually loses some of the dry matter because of the respiration process. And these are parameters related to that and explained in the original paper of SALTMED model and also in the manual, in the user guide. Here there are some stress factors, and that actually here the water uptake effect Some plants that are drought tolerant, they can take water at a potential level up to maybe 50% of the total available water. But some plants, after taking 25% of the available water, then they start reducing the uptake and being subjected to some stress. So 75% availability of the water, this is the cut-off point where the plant, they start decreasing the water uptake from potential to actual. But the drought-tolerant plants, they can go up to 50% or 0.5 to actually to withdraw water at a potential level, even up to 50% of the total available water. These are the minimum and the maximum temperature for growth, because this also has impact on the crop growth and the dry matter building. Rotation, the model would allow single crop, and also the model can allow crop rotation, one crop after the other. So you can call one of the crops here and you add it, and then you go to the year after, 2010, maybe you can also add another one, it will appear here, and then the model would run with one crop after the other. So that's the crop rotation. The nitrogen here in that file is different from the nitrogen added with the irrigation water. The nitrogen added here is added as a dry fertilizers, and that could be manure, could be chemical fertilizers, but that was something you spread over the soil, and is different from what you solve or dissolve in the irrigation water, and that would become part of the irrigation file. So here, if now you want to use manure, then you can go and you put your data, and I'll try to see for a good example here. Nitrogen applications. For example, here this is nitrogen file. So here you have manure bedding, and also you have here manure feces, and then you have manure in ammonia. This comes from the urine of the animals on the straw or the bedding. And here you have crop residues, and also you have here chemical fertilizers, nitrate-based fertilizer or ammonia-based fertilizer. And also you can have urea fertilizer. So all these actually added as dry fertilizers to your soil. There are also some deposition from the air, and it comes with dry deposition here. How many gram nitrogen comes from factories and deposits on the soil, and also you have wet deposition of nitrogen that also comes from the air but precipitated by the rainfall, and we'll put that also in there. And also we have to specify the plowing layer or plowing depth, and also we have to specify the soil moisture at which denitrification process starts, which is usually close to saturation. And the initial values here in the soil, how much really humus in the soil, how much carbon in terms of letters in the soil. So that gives you initial conditions here. There are here some parameters related to nitrogen decomposition or organic matter decomposition, changing from ammonium to nitrate, mineralization, and all those coefficients are here in the database, and you can change them from the database table. These are parameters related to nitrogen uptake by the plant, and these are parameters related to the soil temperature, which is needed in the decomposition of the organic matter and mineralization process. So if really you are not interested in nitrogen, or nitrogen is not important for you, you can just skip the nitrogen completely. So the model run was without nitrogen taken into account. Also, if you're not interested in salinity, you can also skip salinity and you tick the boxes. So the model would run with just water as the main component for the model. A general tab here that would allow you to calculate the metric potential and the conductivity functions using Van Genuchten equation, which is necessarily functions to calculate Richard equations and the changes of moisture and solute transport. The other thing that if you measure this, you can actually go there and interpolate the measured matrix potential and conductivity versus soil moisture table. If you obtain that from field or laboratory measurements, you can actually put that here as a file. And if you want to see what the file is, maybe you can have here a look at one of the files. And here, I'll take this one. And we need to open that with Notepad. So what really you see in that file is that we have here about 20 rows of data. The first column here is the soil moisture, and the second column to the right is the hydraulic conductivity in meter per second. And then the second set of data here is also 20 rows. The first column is the soil moisture, and the second column to the right is the water potential, and that's also expressed as a meter here. So if you have this measured in the field or in the lab, you can actually make that table and then upload it. And if I click on here, then it will appear here with the name. If you don't have that measured, there's no worry, just you can go there and the model will calculate that for you. The other thing also in the model has up to 4 layers to express the heterogeneity in the soil. You need to specify what sort of soil in the top, and that's here, that soil for example, and then the second layer could be something else, could be clay loam, and the third layer could be clay. So you can actually go up to 4 layers maximum to describe the heterogeneity in the soil, and that would sometimes help give you a better estimation. For example, this is sand here. So here you can have different soils, and you have to specify the thickness of each layer, the initial soil moisture content for the first day of model run. You have to specify also the salinity of each layer, the nitrate and the ammonium concentration each layer. So that's, and also you have to specify the site, latitude, longitude, and the elevation about sea level. And that's important when we calculate the radiation in particular for that site. Parameters here that would allow us to specify the flow domain, how much really the width of the flow area that you want to see on the screen, and also how deep you want to see the soil moisture distributed. And here, this is the number of the squares that we specify, and most of the time the default is 4 centimeters by 4 centimeters. And also we give here approximate time for rainfall, and we prefer to have the rainfall specified at different time from irrigation, not to have too much water entering the soil surface at the same time. And also here we have some tortuosity calculations. This is related to the hydrodynamic dispersion of solutes in the soil, and that's explained in equations given in the user's guide. The KR here is reduction factor to reduce the potential soil evaporation to actual, and the explanation of KR is given also in FAO irrigation drainage paper number 56. Also H50, it is the water potential at which the water uptake is reduced to 50% of its potential, and also explained in the user's guide. The model runs with variable time step. Minimum is 25 and the maximum is 300 seconds, but it takes the average on daily basis and plots them as a daily values. The profiles here, the profile tab, actually the first set here would let you decide at what depth, at what distance from the irrigation source you would like to see on the screen the soil moisture, soil salinity, nitrogen during the model run. But the second set here, actually, it allows you to specify at what depth, at what distance from the irrigation source you would like the data to be recorded in the output file in the results folder. And also in some cases here that you would like the model to put the results as an average per layer. In this case, you have to specify the thickness of the layer, for example, starting from 0 to 20 centimeter, second layer from 30 centimeter to 50 centimeter, or from 60 to 80, and or from 80 to 100. So you specify that here as an average values per layer. You would like the model to give you, to calculate the average salinity, moisture, and the nitrogen, and put them in the results file. But if you are interested only at having the results at a certain depth, then you have to generate point observation, which means that concentration and soil moisture at certain point. But if you are interested in having it as a range values, which is average of a layer, then you have to tick the other box. And if you are running the model for a longer period, like 50 or 100 years, especially with climate change scenarios, then you have to send the data to Access database, because Access database can accommodate large size of data as the results of 100 years of run. So that's basically the profile tabs. Don't forget, the first set is what you see on the screen. The second set here is what goes into your data files.